Good afternoon, guys. I hope you are all enjoying the event. It's a really good show. I've been following you on Facebook and seen some pictures and videos. You've got some really exciting and inspiring work. I'm recording this video from the UK. Unfortunately, I can't be there with you to talk in person, and we wanted to do a live webinar yesterday, but we couldn't do so. Instead, I'm recording this video for you and doing the presentation in this video. Hopefully you will enjoy it and you will find it useful. Before I get started, let me introduce myself. My name is Máté Marsalko and I'm a web developer. I've been working with the internet and websites for the last 10 years. And in the recent years, I started dealing with creative technology, which is an actual job title here in the UK. It basically means that as a creative technologist, you have to be aware of all the recent technologies, and then when the client comes to you, you should be able to present ideas around a certain creative concept, and you as a creative technologist, you also produce prototypes and take part in workshops. So I really enjoy working with that. I managed to extend my web developer experience to be a creative technologist, as with that skills, with HTML, CSS, JavaScript, the technologies that you normally use for web development, you can very easily transfer to hardware and electronics and devices. And that's what I would like to talk to you today in my presentation. I hope you will enjoy it, and I'd like to go on to the slides now. Alright, so the title of my presentation is Web Technologies for Hardware Development, and I'd like to explore a couple of ideas around how web technologies like HTML, CSS and JavaScript can help and empower hardware development and electronics. Hopefully I can give you some insights due to my background. So in this presentation we will try to discover 3 key areas how web technologies can help hardware and electronics projects. And just to recap what web technologies I mean, it's basically websites, web applications, web servers, and the programming language behind these is HTML, CSS and JavaScript. So basically your regular web stack that you use to build websites, web applications. But first, before we go ahead with that, let's discuss why web technologies and the internet are getting so popular, and how to use web technologies for hardware development. And in how I mean, how is it technically possible to use just regular website technologies for electronics. So we need to discuss that first. Alright, so why is it getting popular in between developers? That's what I actually mean. So for developers, why do they actually choose to use JavaScript and HTML web languages to develop electronics? And I think the main reason behind this is that web development is easy to learn. There are tons of resources and help online. You have any questions and you can ask on Google. There are answers, and there is a big community, a large community that keeps pushing the limits of what's possible. And pushing the limits is actually one of the main reasons it's getting popular, because there are so many things that you can now do these days with simply a couple of lines of CSS and HTML, that it becomes very, very popular to just simply use these languages. And it's also part of the reason because there are so many web developers out there that at least one of them would try to explore experimental technologies with them. And due to this, websites and the languages, mainly JavaScript, that is responsible for making a website interactive, has currently evolved beyond the browser window, so it's no longer only available to view websites inside the browser. You now have web applications running on Chrome operating system, Firefox, and Android and iOS. So if you want to build your own applications for Android and iOS, you don't necessarily have to learn Java and C# and Swift, so all these higher level languages. You can basically use your existing HTML, CSS and JavaScript knowledge, build a website, add a few extra functionalities, and you can deploy that to the app stores. And there is a new thing called Node.js in the web development community. The idea behind this is that it allows you to use the JavaScript rendering engine from the website, from the browsers outside. So if you take the core engine that's responsible for running JavaScript, that has now been taken out, and you can use it anywhere. So you can run it from the terminal, from the command line, and build applications that simply use the JavaScript rendering engine without an actual website. So this allows web developers to do exciting applications without worrying browser support or browser features or browser limitations. And JavaScript has evolved even further, and you can now find electronic devices and chips and prototyping boards that can run JavaScript on the chip natively, which is really, really exciting. Okay, let's move on to the how. So how is it actually possible to use web technologies for hardware development? So if you compare like regular applications, when you think about a website, JavaScript running in the browser, everything is quite limited. Access to the communication ports like USB, Bluetooth, or hardware components, file systems, these are all restricted because imagine when you go onto a website, you want to make sure that the website can't start accessing your hard drive, extract data, modify data through the file system. You don't want to allow a website to connect to your external USB devices and control your printer, control your webcam. There are necessary restrictions when it comes to the web. Everything is very well limited for security reasons, and it's difficult to argue with that. That's a minimum standard you have to follow when you work with the web. But even with these limitations, there are some very exciting things we can do. There are some features in the browser that allows you to access certain hardware components of a mobile device or a tablet device or a laptop computer. These are, for example, instantiating a phone conversation, text messages through a simple link. So when you click on that link on that website on your mobile device, that click would take you to your mobile phone's native phone application, or pre-compose a text message and take you to your Android or iOS text message application. You can also access the GPS, the global positioning system of your phone. You can access the geolocation of the device and use that. The gyroscope and the accelerometer, these are the sensors your mobile device used to determine the rotation and speed acceleration of your device. So you can use that in the website. You have access from JavaScript to the battery info, how much the device is charged. You can send controls to the vibration motor inside the device for enhanced notifications, for example. And you can also access the device light and proximity sensor. So these are sensors built into most mobile devices to determine the ambient light. So for example, the device light can dim or brighten the screen depending on environmental light, and the proximity sensor is just a sensor to tell that something is close to the device. So the proximity sensor is used for to switch the screen off. So for example, when you take your phone, start a phone conversation, you put the device up to your ear, then certain sensors and the touch screen and these things are switched off, and that's determined by the proximity sensor. So again, you can use these in your website. And there's one very interesting one, the web speech and web synthesis device, which you can use to read certain sentences up from the website or recognize voice commands. So if you want to build a website that takes voice commands, navigations, you can do that. And finally, my favorite one is the Gamepad API, which is a USB connect, which handles USB connected game devices. It can be a joystick, a racing wheel, or a regular Xbox gamepad. And if you work on an HTML5 or JavaScript game, you can extend the controls with these external USB devices. So as you can see, there are a lot of things that you can do in the browser, but these things need to be defined. They are predefined and you can't extend it. So that's the limitation. So if you want to do certain things in the browser, you are limited for the good reason, for security. But yeah, it's good to know that all these things are available for you in case you are actually limited to the browser. But the main idea is, well, I started with Node.js running on the server and outside the browser, is to actually take the JavaScript engine, move it outside the browser, use the same language, but extend it as you wish, because when JavaScript is running on the server, it can access most resources of the computer. It's not limited, and you can connect to external devices, initialize Bluetooth connections, and access the file system. So these are all allowed because right now you're running an application on your computer. You know that you can trust that, so there are no problem with that. Yes, as I said, running your code on the server and sending the data to the browser is one solution. So to work around the restrictions of the browser, you can do the calculations on the server, on your computer, and then send all the processed data, all the sensor data, the things that you don't have access, you send it to the browser. So that's one way of doing it. Now I'd like to show you an example of what I actually mean. Let me start this video. So what you can see here, that we are driving a drone from a JavaScript server. So we have a server running in the background. It handles the inputs from the gamepad and it streams the video signals to the browser. So the whole application, it's not running in the browser, it's running on the computer, it's running on the Node.js JavaScript core. And what happens is that we are communicating with the browser to show the video stream, and we are communicating with the drone to send control devices, control messages. And it works very well. It's very responsive, as you can see. So let's see what happens in the background. So you can see that you have the JavaScript server. It's a standalone application running outside the browser, and we read the signals from the USB gamepad and send the control messages through Wi-Fi to the drone, and we have a second stream which is sending the video signals to the browser. So it works very well. We basically worked around the limitations of the browser and managed to use our existing JavaScript skills to write an application to drive the drone. Here's an example code. I'm not sure how many of you are familiar with JavaScript, but just wanted to show you how easy it is. So I'm including the AR drone library, determining where I want to load the library from. I have the client, which is an instance of the drone. And if you just look at the first 3 lines of code, the third one sends the takeoff command for the drone. So in 3 lines, you can actually start the communication with the drone, all done with JavaScript. So it's a very, very simple interface and language. So I guess some of you are familiar with prototyping boards and electronics, but I wanted to have a quick 5-minute tour of what prototyping boards are actually and how can we use them. So we discussed that from now, we are now outside the browsers. We have access to certain ports, USB ports and sensors, and we managed to control an external device, the drone, and fly it. But what we actually want to do is create our own hardware. We want to install sensors, our own motors, and for that we need something. We need to be able to do electronic components. So the prototyping boards are designed to read sensors and monitor the world. So that's the board is actually what helps you communicate and handle these electronic components. The most common one, the most popular prototyping board is the Arduino, and this is what actually started the revolution. So as far as I remember correctly, the Arduino was introduced around 2005, 2006, and this was the first prototyping board that got really popular in really quick in a really short amount of time, and it allowed non-engineers to start tinkering with electronics. So previously you had to be a really strong electronic engineer, hardware engineer, to build a home automation system or simple circuits, but with the Arduino now non-engineers can start projects, but not just regular developers, for example, or adults, but even kids, because these prototyping tools have evolved to such simplicity. They are so simple now that even kids can create projects with them. And there are specific boards that are designed for web development. So as I showed you previously, there are boards that can run JavaScript on the chip. They can connect to the Wi-Fi, internet very quickly, access web API. So basically working with electronics have now become a really easy and really simple thing to do. And then we have the Raspberry Pi, which is even better, because when you work with regular development boards, for example the Arduino Uno, the processor and the capabilities of that board is quite simple. So you're working on an 8 to 16 megahertz processing speed, so you can't really render a graphical user interface, process sound, voice or camera image. For that you need a proper computer, and that's what the Raspberry Pi gives you. It's a fully functional Linux computer. It has a quad-core processor, but the most important thing is that on top of being a computer, it has GPIO pins, and GPIO pins mean that it allows you to connect to external electronics, so electronic sensors and motors. So it combines both of these things. It gives you the really strong and powerful computer, and also being able to interact with electronics, and that's why it's so powerful. It can also run a desktop Chrome, and yeah, because what you can do with the Raspberry Pi is you can connect an external monitor, you can plug in the HDMI port, you have a monitor, you have USB ports, so you can put keyboard and mouse, video and microphone. So essentially you can run a fully working Chrome instance. As a web developer, you can do your website, you can do your web interface, but at the same time you can now extend your web application with physical components, sensors, buttons and switches, which is really, really powerful. And this can be controlled with JavaScript, so existing knowledge can be used. Raspberry Pi is not expensive. The most expensive ones are around $35–40, but with the Raspberry Pi Zero, they managed to shrink the price down to only $5, and it still has all the components: HDMI, USB, a really powerful processor, and the GPIO pins. Here's the Espruino PICO. This is the development board that can natively run JavaScript on the chip, and it's the development interface SDK is really convenient. You can there is a Chrome application that you can code and upload commands to the chip in real time. So what is basically a prototyping board? The brain of it is the microcontroller. It's that big black chip in the middle. That's the processor. That's what manages all the GPIO pins, all the sensors, all the motors. And the boards, these prototyping boards help power, communicate, and interface with them. So previously, when we didn't have prototyping boards, electronic engineers, they were still working with microcontrollers, but they had to build specific circuits to power, another circuit to communicate and interface. So it was a really time-consuming, and you need to be a very skilled engineer to start building complex projects. But with an Arduino, you straight away have a very convenient way of doing all these tasks. So for example, powering and communicating is as easy as plugging in a USB port, and the whole thing powers up, and you can start straight away. Some of them are special because they give you extra tools like Bluetooth connections and Wi-Fi connections, but in the core, what they mean is managing electronic signals, sending and receiving and processing them. And some of them are fully functional computers like the Raspberry Pi, and some of them are tiny. So let's look at a few of them. You have tiny and simple ones for variable projects, for example, big and versatile with lots of input and output pins. There are ones with built-in Bluetooth, and this one is very cool because what it can do, as soon as you plug it in to the USB, the computer recognizes it as a mouse or a keyboard, so you can add your own sensors to build a custom mouse or a keyboard. This one is for home automations. As you can see, there is a switch, a relay switch on board, and an Ethernet for internet connections. So what is the conclusion from all this? Learning web development and hardware prototyping has both become easy and accessible. JavaScript is, as I said, there are lots of resources, lots of help, training, videos online, very easy to learn. And hardware prototyping with the Arduino and Raspberry Pis again became accessible by non-engineers. So you can now build electronic projects that are controlled by websites and web apps and other web technologies, which is really cool. This is something we haven't had before. Let's go back to our original question and answer: how can web technologies support hardware and electronic projects? And the first one is store and process data. If you think about classic web servers and databases, then it just makes sense to store data on them, not on the client side when you think about web development. So take, for example, a smart desk lamp where there are certain things that you want it to remember. Then it doesn't make sense to store everything on the device itself, because you might want to share the information on an application or a website. Then you take all that data and store it on an external web server in the cloud, in a database. So this makes perfect sense to use classic web technologies to store your data. the server itself can help you validate, organize, and secure this data. You don't need to worry about that. And previously, in the last 10 to 15 years, or even longer, Apache, PHP, and MySQL was the standard stack for web development. But since we are talking about pure front-end technologies like JavaScript, HTML, CSS, and CSS, then it makes sense to now consider a purely JavaScript stack. So it is now possible to, instead of Apache and PHP, simply use JavaScript to handle all the incoming requests, the data processing, and storing everything in a database. So you don't have to learn a new language to do all that, just new APIs. And the server itself, it doesn't have to be an external server in a cloud. You can treat your PC or a Raspberry Pi to be that, especially when you're working on a smaller scale project. It makes sense that you don't pay extra for a server. Just use your own computer or a Raspberry Pi. All these servers and all the processing power they can give you that a very low powered Wi-Fi device or a Wi-Fi development board or an Arduino, they can't give you. Because, for example, the Arduino, it gives you 16 megahertz. That's not enough to do all the calculations. So if you have a powerful processor, a powerful server computer, then you can start processing images, voice. You can connect a camera or a microphone. You can stream that to your server, and you do all the heavy processing on it. If you think about a standard home automation, you have small modules. So for example, you have smart light bulbs, smart temperature sensors, smart outlets, mains outlets, and all they are responsible for is switching, reading sensors. But when they connect to a central module, which can be a Raspberry Pi, for example, then that central module can be responsible for all the data management, all the controls. And you can also filter incoming requests, which obviously don't want all your little modules, the sensors, to handle. You want to have a more powerful device to do that for you. Let's look at the second, how we can use WebTech. And that is displaying data. So now we've stored it, now it's up to displaying it. So imagine that you have accumulated all that data on your server in the database. Now you want to have a nice interface to display it. I mean, if you have just a simple smart light bulb or a smart robot, it doesn't normally have a display to show very sophisticated and detailed information and data. So it makes sense to use a website or a web interface to monitor the data. In case of your home automation, it can be a control panel. So it's not just monitoring the data, but sending control messages as well. And it can't just be just simple charts like we have on the right side, but you can do very rich animations and interactions. You don't have to restrict yourself to simple things. And this is the example I already mentioned to you. So if you imagine that if you have a Raspberry Pi as a central module for all your home automation, it can act as a web server and a control at the same time. So it can manage all the small modules, but at the same time it's a web server. So if you connect to your home automation system, the Raspberry Pi can be your central module that shows a website and shows the controls for you. This development board is one of my favorites. It's called the NodeMCU. It has a Wi-Fi on board straight away. It's really powerful compared to an Arduino, for example. These can go up to, I believe, 120 megahertz. So you can do a bit more calculations, a bit more powerful calculations with it. And you can use the same language. So if you learn the Arduino language or do anything with JavaScript, for example, you can use that same same code with the NodeMCU. But what's really cool about this is that it's cheap enough. This is around $2 to $3. So this prototyping board is cheap enough to build it into a light bulb or a electronic switch, and at the same time as handling all the switching and reading the sensors, it can host a website. So with the Wi-Fi chip on board, when it's powered, when you power it, connect it to a battery, for example, then it connects to your home Wi-Fi and it gets an IP address. And when you connect to that IP address from your mobile device or tablet or laptop, it can serve a website. So in case, for example, you build a smart desk lamp, this device can firstly switch the desk lamp, switch the electronics on it, but at the same time it can host a website. So from your phone you can connect to your lamp, see the details of the lamp, control it, create like really nice HTML and CSS buttons. So for only $2-3 you get what you can do with an Arduino, but at the same time you can serve a website, a control panel. Next, let's look at controlling devices. So when you think about electronic device, most of the times you don't have a touch screen like the one you have on a mobile phone. You don't have a really powerful processor, and it just makes sense not to create a completely new user control. In case of this smart kettle, you can see that it doesn't have a display, so they created a mobile application. So all the data is coming through from the kettle through Wi-Fi to the application, and you have certain controls like timers inside the phone that just sends control messages to the kettle. So by doing that, you're saving a lot of money because you don't have to build that touch screen into the kettle. Instead, you use your existing phone to do all that. So this makes perfect sense. There are multiple ways how you can connect to a smart device. Bluetooth is a very common way. You can connect, if both of the devices have Bluetooth, they are connected to each other directly. Wi-Fi, if they are both Wi-Fi enabled, they can do the same thing. Or if there is an intermediate web server, so for example, if they are both sending these signals up to the cloud, to a cloud database, then the mobile application interfaces with that, so there are no direct connections between them. When you think about classic websites, you think about simple buttons and slides. These controls can translate to changes in the device directly. So if you think about a smart lamp, buttons can switch it on and off, slides can change the color. If you think about the gyroscope inside your phone, which the gyroscope can detect the rotation of your phone and position of it, you can use to control a robot arm, for example, very fine-tuned angles. Or if you have a USB gamepad or a joystick, then you can use that from the website to control a toy car or a radio-controlled car. I'd like to give you an example here. I built this smart desk lamp. My daughter is playing with the controls. You can see that I built a simple HTML website. You have 3 slides for the 3 colors and some buttons. The whole thing is connected to a Raspberry Pi. You can see the big transistor switching the light, the electricity, and there's an RGB LED strip that can change the light. With the combination of the 3 key colors, you can get to 60 million of them. And it's an interesting project because I was using the speech recognition in HTML, so you can tell what color you want, and the speech recognition recognizes it and and switches the color to that. And since this is working with the idea that the website itself is hosted on the Raspberry Pi connected to the Wi-Fi network of my home, what you can do is go to any mobile device or any laptop computer inside the house, go to that IP address, and the same control panel would be displayed. And it's just a very convenient way of giving the opportunity to control these devices instead of, I mean, imagine if I had to build all these controls from physical buttons and slides, it would have been a bit more expensive and time consuming. So let's see how it works. As I said, we have let's go back. So as you can see, we have a Raspberry Pi as the brain of the project. It works as a microcontroller that manages the switch of the electricity to change the light, as well as a web server hosting the website and reading the control messages from the browser from any device connected to it. So it does two things at the same time. Here's a second example. This is a toy car I got from my previous boss, and I got rid of the internal circuits, the original one that it came with, and I rebuilt the motor controls with Arduino. So as you can see, I have a Arduino Mini Pro. I have the motor drive unit and a wireless connection. And the idea behind this is that, again, I'm using the Gamepad API. This time it's connected to a racing wheel and pedals. The website with JavaScript recognizes the control from the wheel, and it transfers it to an Arduino, which in return drives the car. So again, as you can see, with web technologies, with JavaScript, we are making a very complex project. You can see my colleagues playing with that. It was a lot of fun. Let's see how it works. So as you can see, you have on the right top corner, you have the browser, and the racing wheel and the pedal is connected with USB, and the browser itself, the web application, can detect the control signals from the joystick, and that transfers all the control messages to the central computer with the JavaScript server on it. And all these control messages are transferred to an Arduino, which is connected to the laptop itself. And then there's a second Arduino inside the car, which is only responsible for communicating with the other Arduino, receiving the signals. So there's a lot going on in this project. There are a lot of stages. We're coming from the browser to a server and into one Arduino and wirelessly connecting to another Arduino. And there's a very exciting thing going on with Siri and JavaScript. So I'm not sure if you heard about, but Apple as well as Google, they are both really interesting and exciting in the home automation and smart home accessories businesses. So recently Apple has released HomeKit, which gives you a very nice application and the ability to connect to smart devices. So they already partnered with dozens and dozens of manufacturers, so you can buy smart lamps, smart accessories, security systems, and you can control and monitor all of them through their HomeKit application. But the cool thing is that as soon as you manage to pair your device with HomeKit, then Siri, the voice assistant you have in iOS, can control and give you feedback from it. So essentially you get a voice control over your smart home. And Homebridge is a JavaScript library that allows you to connect to this system. So you take your existing or take your new Arduino project or Raspberry Pi project, your sensors and controls and motors, and you set up a JavaScript server. So the server is running again on your laptop or your Raspberry Pi, and it creates a bridge between your Arduino and the HomeKit. So as soon as you have your Arduino set up, what you can do is set up certain URLs for your devices. So you list all your URLs for all of your Arduino devices in this JavaScript server, and from that point HomeKit and Siri, they can recognize it as genuine accessories. So in case of, let's say you have a smart sensor in your living room, then you build your Arduino, you connect your temperature sensor, and you connect a Wi-Fi module to it. So you have to make sure that somehow your Arduino project connects to the Wi-Fi. So to do that, you can use the NodeMCU, which I showed you earlier, the $3 Arduino compatible board, which can straight away connect to the Wi-Fi because it's got a Wi-Fi chip on it, but at the same time it can connect to sensors. So imagine that you have a sensor connected to the Wi-Fi, then Homebridge will get an IP address and a link to it. So you can say IP address / get temperature, and your smart device, the Arduino or the NodeMCU, will respond to that get temperature URL, and with that you basically connected the whole project to iOS and the HomeKit and Siri. So you can just go into your Siri and ask for the temperature in the living room, and it would connect to your project. So it's a really, really powerful thing, because from this point on, you don't have to worry about building your own web applications, controls, or websites. You set up the necessary URLs for these devices, and the whole thing will be connected to Homebridge. It's really, really powerful. As I said, it can, just to reiterate, you can use a Raspberry Pi or a NodeMCU. You don't necessarily have to have a laptop computer running constantly. You can rely on these cheaper devices to control your home automation. And this is the application you get. So it's really cool. You see all of these, you have different rooms, different settings, and different devices all connected to this application. So it's really nice to think that with a couple of lines of JavaScript, you can make your projects, your electronic projects, connect to this ecosystem. And the same thing can be done with Google's Home proposal, and you also probably heard about Amazon Echo, which is a smart assistant. They can all be extended using JavaScript to connect to your electronic projects. So now we've already discussed what web technologies can do for hardware, but let's now discuss how can hardware and electronics support web projects, because this is really important for web developers. What can they get from learning electronics? So what you can see on the picture is this is two photos from the Science Museum, and you can see that the kids are playing with interactive games. So on the left you can see that they are looking at a display. So there is a graphical interface, a website going on, probably something with web technologies or an application. At the same time, instead of just using a mouse and a keyboard or a touch screen, they have physical controls like buttons, slides, sensors, which is really cool because you can do interactive experiences. And it's not just in museums. You can think about interactive installations in a shop environment or a shopping mall or on the street. People can interact with your website through physical buttons and sensors. Here's another example. On the left you can see an office dashboard. So this would be a screen constantly up on the wall in an office, for example, connected to a web server. Again, it can be a Raspberry Pi, and it doesn't have to be an application. Think about web technologies. You can what you can see on the left, it can be a simple website. You can run Chrome in full screen. No one would notice that you're actually running this in Chrome. You can build a very simple HTML CSS website and display this, and the edit functionality that electronics and sensors can give you is to make this really smart. So you can install sensors in the office, motion sensors, temperature sensors, all contributing to a very live dashboard. And on the right you can again see different buttons and dials that you could be used to build games and stuff. So how does it work? Very simple. You have could be a Raspberry Pi or another computer which handles the sensors, all the signals from sensors, and you have a monitor connected to it, and Chrome or any other browser running in full screen mode. And you don't notice that behind that kiosk or interactive experience in the shop or a museum, there really is nothing else, just HTML and CSS and simple web technology. So this is a very powerful thing for if you think about web developers. Here's a very cool example. This is again my daughter playing around with this gyroscope, and what we're doing is interpreting the gyroscope signals with an Arduino, and the Arduino is connected to Chrome, and that cube is built with CSS. So again, we are using a physical sensor to control a website. You can see the workflow again. You have the JavaScript server and an Arduino and the gyroscope all connected to the browser in real time. And you can see that I always list WebSockets here. WebSocket allows you to open up a stream between the server and the browser, so the messages from the server to the browser are all real time. Here's another example. This is an interactive dashboard I built for a previous company I worked for. So you can see that the employees can post posts and photos onto this TV, and I'm controlling it with a KINECT. So what you can see on the top of the TV is a KINECT sensor. A KINECT is basically for the Xbox, for games where you want to track the whole body of the player, and I'm interpreting the gestures with that and sending it to a full screen Chrome web application. So you can see again that the KINECT communicates with JavaScript, sending the signals to the browser again. So what's the takeaway? Let's discuss what we've learned from all of this. So for web developers, the takeaway is that hardware and electronics prototyping can be easy to learn and definitely a valuable skill, because as a web developer, if you can use your existing skills, I mean, nothing prevents you from learning new things, but if you can use your existing skills straight away to build electronics and physical experiences, that's a very powerful thing. And when these physical devices and kiosks and home automation projects are something that you previously were unable to do, and you always think, as a web developer, when you look at these projects, you always think that you need to be an engineer, electronic engineer, or you need to at least learn a different language like C++. But it's very powerful that existing knowledge can be used to build so different and so powerful things. And the Arduino and the Raspberry Pi are really invaluable tools for this, as they allow you to use your existing skills. And what's the takeaway for electronic developers or electronic engineers? I think it is that web technologies are essential for rich and outstanding electronic projects. It can help store, process, and display data and control devices through graphical interfaces, websites, or mobile apps. And it gives you experimental technologies like voice and image recognition, because you're now using a central server which can give you lots of processing power, and the whole thing can be built on top of JavaScript. And HTML, CSS and JavaScript, the language of the internet, is very easy to learn, as there are tons of resources, tons of help. JavaScript is just one of the most popular languages these days, so you will get a lot of help, and in a very short amount of time you can get a lot of things done. So thank you for your time and listening to my talk. I hope you enjoyed it, and if you would like to see a couple of more projects from me, you can visit my website, webondevices.com. If you're a web developer interested in learning electronics, definitely check out my free ebook. Again, if you're an electronic engineer, would like to learn about JavaScript and web technologies, you can download my free ebook, because it starts from the very basics and it can teach you a lot of cool things around that. As I'm not here with you right now live, I can't answer questions straight away, but I'm happy to help. Feel free to send me an email. If you go to my website, you will find my email. I will answer any questions, and most of the times people send me messages to help with existing or new projects, and I always help them and guide them through new projects. So if you're thinking about getting started with any of these things or technologies you've seen, or if you see something else on my website, you can definitely email me, and I'm happy to help you. So thanks for your time, and I hope you enjoyed it. See you guys.